Good morning. Next acid derivative is amide, RCO, NH2. Amide. Preparation. From first method, from acid chloride, RCOCl treated with ammonia NH3, we get RCONH2 plus HCl. Second method, from anhydride, RCO OCO R dash treated with ammonia NH3 RCONH2 plus R dot COOH. Here you can see that RCO from NH3 NH2. So RCO NH2, then remaining R dot COO, one H is here. So R dot COOH. Okay. So this is the method of preparation of amide. Okay, first method from acid chloride, second method from anhydride. When acid chloride or anhydride is treated with ammonia, we get amide. Reactions. Look at it here. RCONH2 on hydrolysis H2O. We get RCOOH, carboxylic acid, or reaction with nitrous acid. Again we get carboxylic acid, RCOH. Now you can see that reduction with lithium aluminium hydride LiAlH4, or you can use sodium in presence of ethanol C2H5OH. Okay. Reduction with lithium aluminum hydride or sodium and ethanol, we get RCONH2 will be changed to RCH2NH2. Will get amine. Next is dehydration reaction. Dehydration. That means when treated with P2O5, water molecule will be eliminated, minus H2O, and what we get RCN, H2O is eliminating, and we get RCN. Okay, so these are the few reactions of amide. First one is hydrolysis, will change into the corresponding carboxylic acid. Again, with the nitrous acid also we are getting the carboxylic acid. Now you can see that reduction with the lithium aluminum hydride or sodium in presence of ethanol, RCONH2 will be converted to RCH2NH2, and dehydration reaction, that means amide on treatment with P2O5, water molecule will be eliminated and we get RCN, nitride. Next, another important reaction of amide is Hofmann bromide reaction. Hofmann bromide reaction, or for Hofmann degradation reaction. Hofmann bromide reaction or Hofmann degradation reaction. This is the reaction of amide with bromine in presence of NaOH will get an amine which contain one carbon less than that in the starting amide. Once again, so reaction of amide, look at here, RCONH2, reaction of amide with bromine Br2 in presence of NaOH, then we get a primary amine with one carbon less than that in the starting amide. So you are getting RCONH2 will be converted to RNH2. This reaction is known as Hofmann bromide reaction. Example, you look at here, CH3CONH2. Okay, CH3CONH2. Now you can see that this amide is containing two carbon atom. When it is treated with Br2 in presence of NaOH, you get an amine which contain one carbon less than that in the amide. So you get an amine with here you are having two carbon, therefore we get an amine with one carbon, that is CH3 NH2. So acetamide is converting to methylamine. So suppose the question will be like this: how will you convert acetamide to methylamine? So keep it in mind, acetamide is containing 2 carbon and our methylamine is containing only 1 carbon. Therefore, the reaction is Hofmann bromide reaction. Next is next derivative is esters. Ester. Preparation. As we know that ester is prepared from by the reaction of carboxylic acid with alcohol or OH in presence of concentrated H2SO4. H2O will be eliminated. And we get RCO R dash plus H2. This reaction is very familiar to you. Ester is manufactured from carboxylic acid and alcohol in the presence of concentrated H2O, so forth. Now, reactions of ester. The important reaction of ester is hydrolysis. Okay, hydrolysis of ester. And in hydrolysis, there are 2 types of hydrolysis. First one is acid hydrolysis. That means the hydrolysis of ester or C double bond O add dot, okay, is hydrolyzed H2O in presence of acid. Actually, this is a reversible reaction. We get the corresponding acid. That means RCOOH plus what we get R dot OH. It will change back to the corresponding carboxylic acid and alcohol. So keep it in mind, RC double bond OH, H2O means H and OH, RC double bond OH. Okay, then R dot O, one H is here, R dot OH. This is acid hydrolysis, and acid hydrolysis is a reversible reaction. Now next is basic hydrolysis or alkaline hydrolysis. That is important. Alkaline hydrolysis of ester. Alkaline hydrolysis. So when the ester is hydrolyzed with a base, we get sodium salt of the carboxylic acid. And an alcohol. This reaction is known as saponification reaction. The alkaline hydrolysis of ester is also known as saponification reaction. That means hydrolysis of an ester with a base will give sodium salt of the acid and an alcohol. So look at it here, RC double bond OR dot. This is an ester. When hydrolyzed with a base NaOH, hydrolyzed with a base, what do we get? RCOO Na, sodium salt of the acid, RCONA plus what will form R dot OH. This reaction is known as saponification reaction. This saponification reaction is used for the preparation of soaps. So look at here, we take an ester, look at here, CH2O, C double bond O, C2H5, sorry, C17H35, and here it is CHO, C double bond O, C17H35, and here it is CH2O, C double bond O, C17H35. This is ester of stearic acid. So it is triglyceryl stearate. This is ester. Present the fat or oil. Okay, so triglyceryl stearate. This is the ester. When it is treated with NaOH, see here you need 2 molecules of NaOH. Then what will happen? You can see that this part CH2O will take H, CH2OH. So we get CH2OH and CHOH, and here it is CH2OH, because here you are having 3 molecules of NaOH, CH2OH, CHOH and CH2OH. The remaining C17H35, C double bond O, O-N-A, C17H35, C double bond O-N-A. So how many molecules you are plus? You get 3 molecules of 3 C17 H35 COO-Na. This is sodium stearate. What is this one? Sodium stearate, which is known as, this is soap. This is soap, sodium stearate. Okay. So this reaction is known as a saponification reaction. So what is saponification reaction? The alkaline hydrolysis of an ester to give this is glycerol and sodium salt of the acid. Okay, sodium salt of higher fatty acid, which is known as soap. Next is another important reaction of ester is transesterification reaction. What is that? Transesterification reaction. Look at it here. Next is transesterification reaction. What do you mean by transesterification? This is when an ester is heated with or distilled with when an ester is heated under reflex with a large excess of alcohol in the presence of an acid. The alkoxy part will undergo a rearrangement and to give new ester and a new alcohol. So once again, when an ester is heated under reflex with an alcohol, so look at it here. When an ester RC double bond O R dot, this is an ester, is heated with under reflex with a large excess of an alcohol. I am taking alcohol R2 dot OH. Okay, in the presence of an acid, the alkoxy part, this RO group, this R dot O, this alkoxy group will undergo a exchange reaction, to give. That means you can see that here you are getting a new ester and a new alcohol. What do you mean by an exchange reaction? Here it is RCOO dash. Now during this reaction you can see that this R dot will be exchanged with R2 dot. So you are getting a new ester RC double bond O R double dot. Okay, R dot double dot plus, but you are getting a new alcohol R dot OH. Here you are getting R dot OH. Clear? This reaction is known as a transesterification reaction. So transesterification reaction means the reaction of when an ester is heated with an alcohol in the presence of an acid, the alkoxy part, will undergo exchange reaction. That means R dot will be exchanged with R2 dot. So we get a new ester RC double bond O R2 dot. Plus what do we get? R dot OH. This reaction is known as a transesterification reaction. Now next last one, reduction reaction of ester. First one is catalytic reduction. Catalytic reduction. Okay, catalytic reduction when RC double bond O R dot is reduced with hydrogen in presence of copper chromate at 200 to 300 degrees Celsius and at 200 to 300 atm pressure. Okay, what will happen? We get RCH2OH. We get RCH2OH plus R dot OH. RCH2OH plus R dot OH. Okay. Now next is chemical reduction. Last one, reduction. First one is catalytic reduction, and the second one is chemical reduction. Okay. This is known as Bowalt blank reduction. Bowalt B-A-U-L-T, Bowalt blank, B-L-A-N-C, blank reduction, or blank reduction. Okay, so again, when ester RC double bond O R dot, okay, when reduced with sodium and ethanol, Na and alcohol, sodium and ethanol, okay, or LiAlH4 with the aluminum hydride, you are getting the same product, or CH2OH plus or dot OH. Okay, so that's all about esters. Okay, so reduction, catalytic reduction and chemical reduction, it's known as Bowart-Blank reduction. Okay, thank you.